Hello everyone, in this video we are doing organic chemistry, specifically esters. By the end of this video, you will see exactly how to answer questions involving esters. Like, if you are ready, subscribe for more organic chemistry videos and drop organic chemistry in the comments. By the end of this video, we will achieve the following goals. We will learn how to define an ester. We will learn how to define esterification. We'll learn how to state the products and reactants in esterification. We'll learn how to identify the ester linkage, name the simple esters correctly. We will also learn the chemical and structural formulas of esters, as well as the key properties and uses of esters. So let's dive in. So we'll start by defining what an ester is. So what are esters? Are sweet smelling compounds formed when a carboxylic acid reacts with an alcohol, and this process is called esterification. So esterification is the process by which a carboxylic acid reacts with an alcohol to form an ester and water. So not only is an ester formed, but also water. So water is a byproduct of esterification. So not only is an ester formed, but also water is also formed. And this process is called esterification. So the general idea of esterification is that a carboxylic acid will react with an alcohol to form an ester and water. So the general idea is that a carboxylic acid will react with an alcohol to form an ester and water. So how does an ester linkage look like? So the ester linkage is this one here. It is COO. In between the carbon and the oxygen, there's a double bond. Don't forget, it is COO. So the linkage is why the compound is called an ester. The reason why we call the compounds esters because they have an ester linkage. So the ester linkage is the reason why the compound is called an ester. I hope that's clear. So what happens during esterification? So what happens is that an alcohol reacts with a carboxylic acid to form an ester and water. I already went through that. So esterification is simply the process by which an alcohol reacts with a carboxylic acid to form an ester and water. So esterification is simply the process by which an alcohol reacts with carboxylic acid to form an ester and water. And this reaction, esterification, is a reversible reaction. As you can see, these arrows here show that it is a reversible reaction. So when a carboxylic acid reacts with an alcohol, what is formed is an ester and water. And this reaction is called esterification. Now the reverse reaction of esterification is called hydrolysis. When an ester reacts with water, what will be formed will be a carboxylic acid and an alcohol, and this process is called hydrolysis. Hydrolysis is a reverse reaction of esterification. Hydrolysis is simply the process by which an ester reacts with water to form a carboxylic acid and an alcohol, while esterification is the process by which an alcohol reacts with a carboxylic acid to form an ester and water. So esterification is reversible. This is why when you want to prepare an ester in the laboratory, when you react a carboxylic acid and an alcohol, you form an ester and water. So in order to prevent the reverse reaction of esterification, what happens is that you add concentrated sulfuric acid so that the concentrated sulfuric acid absorbs all the water. Otherwise, if you do not add concentrated sulfuric acid, the water that is formed as well as the ester will react again to form the carboxylic acid and an alcohol, and you'll be back to square one. So that's why sulfuric acid is added to remove water, to prevent hydrolysis, which is a reverse reaction of esterification. So how is the ester linkage formed? So the ester linkage is simply this one here, COO. So how is this ester linkage formed? So when the alcohol reacts with the carboxylic acid, the ester linkage will be formed. So how is it formed? So what will happen is, we know that the byproduct of esterification is water, right? So I'll first show you how water is formed, then how the ester linkage is formed. So what will happen for water to be formed is that the alcohol will donate hydrogen, while the carboxylic acid will donate hydroxide, OH. So hydrogen plus OH, hydrogen plus hydroxide will give you water. So that's how the water is formed. Then whatever remains is the ester linkage. So the CO for the carboxylic acid plus the oxygen for the alcohol will form the ester linkage. I said for the ester linkage to be formed, what will happen is that the alcohol will donate hydrogen, while the carboxylic acid will donate OH, and the hydrogen will react with the OH, which is the hydroxide, to form water. And then whatever remains is the ester linkage. CO for the carboxylic acid plus the oxygen from the alcohol will give you the ester linkage. So that's how the ester linkage is formed. So how do you name an ester? So there are 3 steps involved in naming an ester. So step 1, for example, if we have a reaction, let me give you this example here. Ethanol plus ethanoic acid. Ethanol, we all know, is an alcohol. All alcohols end with ano, and the ethanoic acid is a carboxylic acid. All carboxylic acids end with anoic. So an alcohol reacts. So we have ethanol reacting with ethanoic acid. So, and ethanol is an alcohol, while ethanoic acid is a carboxylic acid. So when an alcohol and a carboxylic acid react, an ester is formed. So how did I come up with the name ethyl ethanoate as the ester? So the first step to write the ester is start with the name of the alcohol. Change the ending ano to YL. So the name of the alcohol here given is ethanol. So you change the name, which is ending. You change the name. You change the name how? By changing the ending ANOL to YL to YL. So ano will change to YL. So we have ethyl, we have ethanol here, right? To change to ethyl. So the ano will be removed and will be replaced with YL. So to change to ethyl. Then the next step 2, is you change the name of the carboxylic acid, the ending of the carboxylic acid, from OIC to OATE. For example, ethanoic acid, you replace OIC to OATE. Then it's going to be ethanoate. So the ester formed will be ethyl ethanoate, like that, ethyl ethanoate. So step 3, write the alcohol part first and the acid part second. So always remember to write the alcohol part first. So the ethyl will come first for the alcohol, plus the ethanoate for the carboxylic acid. Always start with the alcohol. For example, if you have another example here given is if you have propanol reacting with butanoic acid. So the first step is to change the ending of the alcohol from ano to YL. So propanol will change to propyl. Then the next thing is to change the ending of the carboxylic acid from OIC to OATE. So from butanoic acid it will change to butanoate. So propyl butanoate. Then you combine the two, propyl plus butanoate. So it's going to be propyl butanoate. And then if you have the other example is butanol plus pentanoic acid. So the first step is to change the ending of the alcohol from ano to YL. So it's going to be butyl. Then change the ending of the carboxylic acid from OIC to OATE. It's going to be butyl pentanoate. So that's how you name an ester. That's how you write an ester in words. So always remember to start with the alcohol part, then end with the carboxylic acid part. Then we move on to the next slide. So how to write, the next thing we're going to look at is how to write the chemical formula of an ester. So how do you write the chemical formula of an ester? For example, the example here given is if we have ethanol plus ethanoic acid, will give us ethyl ethanoate plus water, because water is a byproduct of esterification, right? Yes. So now, how do you write the chemical formula for an ester? So start by writing the chemical formula of the alcohol given here. We have ethane. So how do you write the chemical formula of ethane? So all alcohols obey the general formula CnH2n plus 1OH. I'm sure I remember this when you were talking about when you looked at alcohols with your teacher. So this is the general formula CnH2n plus 1OH. So if you remember, eth means 2. So eth means 2. So where there's n, eth means 2 carbon atoms. So where there's n stands for the number of carbon atoms. And if eth means 2 carbon atoms, we'll put 2 there because eth means 2. So we're going to replace n with 2. So where there's n, we'll put 2. So it's going to be C2. Then there it's going to be 2 times 2, 4 plus 1, 5. So C2H5OH. So that's the chemical formula of ethane. Then it's reacting with ethanoic acid. How do you write the chemical formula for ethanoic acid? So all carboxylic acids obey the formula CnH2n plus 1 COOH. So ethanoic acid, eth as well means 2. So we would put 2 where there's n, but the problem is that carboxylic acids, in their functional group there's an extra carbon atom. So let me show you what I mean. So the functional group of alcohols is OH. As you can see, there's no carbon atom in the functional group. But for carboxylic acids, the functional group is COOH. So there's an extra carbon atom in the functional group, this one here. So because of this extra carbon atom, we will not put 2 directly because we know eth means 2. Would put where there's n and put 2, but because of the extra carbon atom here, we will not put 2. We say 2 minus 1 because there's an extra carbon atom, and this will give us 1. So where there's n, we'll put 1 instead of 2 because there's an extra carbon atom in the functional group of carboxylic acids. So yeah, so we'll put 1 instead of 2. So C, when you put 1 there, it's still going to be C. Then when you put 1 there, it's going to be 2 multiplied by 1, 2 plus 1, 3. So CH3COOH. So that's the chemical formula for ethanoic acid. Now, how do you write the chemical formula of the ester ethyl ethanoate? So ethyl ethanoate, the first thing you're supposed to do is write the formula for the alcohol and the carboxylic acid, which we already have. We've written the chemical formula for the alcohol and written the chemical formula for the carboxylic acid. Then the next thing is remove H from the acid group, which is the carboxylic acid. So when you remove this H here at the end, I'm talking about the H at the end, this one I've just highlighted. When you remove it, then you put it here. Here you put it there. Then after that, remove OH from the alcohol. When you remove this OH from this alcohol, you remove OH from the alcohol. Then after you remove OH from the alcohol, you join the remaining parts. So you join this part and this part, and it should look like this one here. So then while we're removing H and OH, because H and OH will combine to form water. If you remember, when I was talking about how the ester linkage is formed, I said H is removed from the alcohol while OH from the carboxylic acid. So as you can see, it's different the way I've done it here, because this is just to help you remember how to write the name of the ester. But what really happens is that the alcohol will lose H while the carboxylic acid will lose OH. But I'm just doing this because it will help you name the ester faster. That way it's just a memory aid. Helps you remember how to write the name of the chemical formula of the ester. But what really happens is that the alcohol will lose hydrogen while the carboxylic acid loses hydroxide. Then the hydrogen will combine with hydroxide to form water. So this is just helping you know how to write the chemical formula of an ester. So if you want to write the chemical formula of an ester, what will happen is you remove the hydrogen at the end, then you put it without the hydrogen, then you remove the hydroxide at the end from the alcohol, then you get whatever is remaining for the alcohol and combine it with whatever is remaining for the carboxylic acid, then you write water. So that's how you write the chemical formula of an ester. So then I'm going to look at another example here. So ethanol plus ethanoic acid will give you ethyl ethanoate plus water. Okay, so we've gone through everything here. So this is just the ester product. Yeah, we've gone through everything here. So just move on to the next slide. So how do you write the structural formula? How do you write the structural formula of ethyl ethanoate? So write the structural formula of ethyl ethanoate. It's first, before you write the structural formula of ethyl ethanoate, you have to write the chemical formula of ethyl ethanoate, which is here. And I already explained how to write the chemical formula for ethyl ethanoate. This is the chemical formula for ethyl ethanoate. So if you have the chemical formula for ethyl ethanoate, you can easily write the structural formula. How? So you're going to ask yourself, what's the first letter? It's one carbon, right? Yeah, so you write one carbon here. Then this carbon is surrounded by how many hydrogen atoms? 3, right? Yeah, CH3, right? So you write 3 surrounding it like that. Then you write COO. Don't forget to put a double bond between the carbon and the oxygen, because this was previously the carboxylic acid, and their functional group looks like this. Yeah, like that. So this went. So don't forget to put the double bond in between the carbon and the oxygen. Now don't forget to put the double bond in between the carbon and the oxygen. So then you write COO like that, following the order, the same order in the chemical formula. Then you write 2 carbon atoms, 2, and these 2 carbon atoms are surrounded by how many hydrogen atoms? 5. 1, 2, 3, 4, 5. So that's how you write the structural formula of ethyl ethanoate. So the key is just to know how to write the chemical formula of ethyl ethanoate. Once you know how to write the chemical formula for ethyl ethanoate, you follow the same order to write the structural formula. So then we have example 2. What if we have butanol reacting with pentanoic acid? So remember, how do you write the name of the ester in words? You first change the ending of the alcohol from ano to YL. So it's going to be butyl. Then the next thing you're going to do is change the ending of the carboxylic acid from anoic to anoate. So it's going to be pentanoate. So butyl pentanoate. Then you combine them to get butyl pentanoate plus water. So now what about the molecular equation for this word equation? How do you write the molecular equation? So how do I write the molecular equation for this word equation? So first start by writing the chemical formula or molecular formula for butane. So all alcohols obey the journal formula, this one here. This journal formula CnH2n plus 1 OH. And butanol, but means 4. So in place of n we put 4. So C4, then put there 4. 4 multiplied by 2, 8 plus 1, 9. So C4H9OH. Like that. So C4H9OH. What about pentanoic acid? Or carboxylic acid will obey this formula here. CnH2n plus 1 COOH. So pentanoic acid, pent means 5. So, but because of the extra carbon atom in the functional group, this extra carbon atom, we'll say 5 minus 1. That will give you 4. So where there's n, you put 4. So it's going to be C4, then 2 multiplied by 4, 8 plus 1, 9. So C4H9COOH. So C4H9COOH. And if you count the number of carbon atoms, it's 5. There are 4 there, plus this one, 5. Pent means 5 carbon atoms. So it balances. If you had put 5 directly, you would have had 6 carbon atoms and it wouldn't have made sense. That's why I say -1, because there's an extra carbon atom in the functional group. Now, how do you write the chemical formula of the ester formed, butyl pentanoate? So I said the first thing is you remove the hydrogen atom at the end of the carboxylic acid, and then you write it. Then you remove the hydroxide from the alcohol. Then you combine whatever is remaining for the alcohol to whatever is remaining for the carboxylic acid, and then you have this. Then you write water. So that's how you write the molecular formula for butyl pentanoate. Okay, I hope that's clear. Now, what about the structural formula? So how are we going to write the structural formula for butyl pentanoate? I said before you write the structural formula of any ester, you first write the chemical formula of that ester. So the chemical formula of butyl pentanoate is C4H9COO, C4H9. So now, I said you follow the same order in the chemical formula. So there are 4 carbon atoms. You write 1, 2, 3, 4. Then they're surrounded by how many hydrogen atoms? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then COO. So COO, which is the ester linkage. Then 4 carbon atoms again. You write 1, 2, 3, 4, surrounded by 9 hydrogen atoms, like that. It's easy once you know the chemical formula, how to write the chemical formula of an ester. Then the structural formula will be very easy. Then move on to the differences between esterification and neutralization. So esterification is a reversible reaction. The reverse reaction of esterification is called hydrolysis. So esterification can be reversed, while neutralization cannot be reversed. It's not a reversible reaction. So esterification produces an ester and water, while neutralization produces a salt and usually water. Esterification is slower than neutralization. Neutralization is faster. Esterification uses a carboxylic acid and an alcohol, while neutralization uses an acid and a base. So those are the differences between esterification and neutralization. So what are the properties of esters? So the special properties of esters is that esters have a pleasant or sweet smell. This is the reason why they are used in perfumes and flavorings. Other points is that different esters have different smells. So depending on what type of ester that compound is, it has a different smell. So butyl pentanoate has a different smell from ethyl ethanoate. That's what it simply means. So the examples of the uses of esters in everyday life is that it is used in perfumes, food flavorings, and sweet scents. So what are the main uses? This is just a repeat of what I just said. Used in perfumes because many esters smell pleasant. Used in food and drink flavorings. Used in some solvents and in making plastics. Small amounts can be used to create a fruit-like smell in products. Example: ethyl ethanoate has a pleasant smell and is a common classroom example of an ester. Remember, the attractive smells of esters come from their structure, especially the ester linkage and the carbon chains attached to it. So what is the summary of whatever I've just said? So esters are sweet-smelling compounds formed when a carboxylic acid reacts with an alcohol, and this process is called esterification. So esterification is the process by which a carboxylic acid and an alcohol react to form an ester and water. So esterification is a reversible reaction. The reverse reaction is hydrolysis. So esterification can be reversed. So when the carboxylic acid and the alcohol react, an ester and water will be formed. So when the ester reacts with water to form a carboxylic acid and an alcohol, it's called hydrolysis. So to name an ester, change the alcohol ending to YL and the acid ending to OATE. So an ester contains the ester linkage COO. Esters are used in perfumes, food flavorings, solvents, and other products. So memory tip: alcohol gives YL, but while the acid OATE. So here's some questions you can try out. So what is an ester? What two reactants form an ester? What is the name of the process that forms an ester? Why is esterification called a reversible reaction? Name the ester formed by ethanol and ethanoic acid. State two uses of esters. Here's another challenge you can do. Name the ester formed when butanol reacts with propanoic acid. Write the word equation and the molecular equation. So you can write the answers in the comments. So this is the end of the video. Have a great day.